The universe is utterly and terrifyingly vast. Humans' inquisitive nature has driven them to learn anything they can about everything in this universe, or even before this known universe. And the most important of all is to find the answers to "Are we alone in the universe?" question. Scientists have been working around the clock and spending billions of dollars to learn more and more about our planet's origins, the Big Bang Theory, the intergalactic space, and everything that is beyond. Seems like their hard work paid off in the form of a giant telescope, the James Webb Space Telescope. Welcome to Cosmos Lab, your one station for all the news from space. Join us in today's video to find out about the massive telescope that is going to answer the existential questions. The James Webb Telescope, an engineering masterpiece and the most powerful space observatory ever built, will help answer fundamental questions about the universe by peeking back 14 billion years. Work on the project began over 30 years ago at Space Telescope Science Institute with a challenge from Institute Director Riccardo Giacconi to think about the next major mission behind Hubble. The masterpiece, James Webb, is the product of the combined scientific prowess of NASA, the European Space Agency, or ESA, and the Canadian Space Agency, or CSA, and by extension, Université de Montréal. The components supplied by the CSA, NASA, and the ESA combine to make the most complex, precise, and powerful space observatory ever built, promising groundbreaking astronomical discoveries. René Déon, Director of Université de Montréal's Institute for Research on Exoplanets, or IREX, and professor in the physics department, is the primary investigator on the Canadian scientific team, which supplied a scientific instrument and a guiding sensor to the enormous observatory. The observatory's unmatched power will allow scientists all over the world to peer into the furthest reaches of our universe to discover more about the composition and habitability of exoplanets, as well as analyze the life cycle of stars. The telescope will explore many things, but the most important of all will be to search for life on other planets. Webb will conduct in-depth research on the planets in our solar system and other planetary systems. It will also detect the presence of extraterrestrial bodies. Furthermore, Déon's team's scientific equipment is capable of analyzing a wide range of celestial bodies, including the atmospheric composition of distant exoplanets. Nathalie Ouellette, an astrophysicist who does communications for the James Webb, said, "What we're looking for, our holy grail, are biosignatures, that is, signs of extraterrestrial life. We're talking about finding signs of biological activity or the signature of certain molecules. Based on the presence of such molecules, particularly in certain combinations, we may be able to determine that conditions are conducive to the development of life when we explore an exoplanet using the telescope." Telescopes are also time machines of a sort, Natasha said. "Looking into space is like looking into the past. Light waves travel so quickly that they appear to flash from one spot to another to the human eye. However, in space, the distances are so great that the time it takes for light to travel is unnoticeable. That makes the Webb a marvelous time machine. It will be able to travel back in time 200 million years after the Big Bang, which is unprecedented. As a result, the Webb will help us better understand how the first luminous objects, the galaxies, evolved through time. The telescope, according to Ouellette, will also provide information on the formation of our own solar system. JWST will also target each of the 7 rocky, roughly Earth-sized worlds in the TRAPPIST-1 system. But how will the James Webb Space Telescope be able to perform all of these functions? The James Webb Telescope is the successor to the Hubble Space Telescope, but it is more precise and efficient because of the size of its mirror, the range of light it can detect, and its location. The primary mirror, a concave structure 21.5 feet wide and made up of 18 smaller hexagonal mirrors, is the focal point of the telescope. When compared to Hubble's mirror, Webb's mirror is about an order of magnitude lighter per unit area. Each of the 18 hexagonal segments is constructed of beryllium, a lightweight metal that weighs only 46 pounds or 20 kilograms. Despite its vast size, the entire spacecraft weighs only 6.5 metric tons, compared to 11.1 metric tons for Hubble. The mirror's surface is gold-plated, giving the characteristic of yellow tinge. The gold tint was chosen because it is far better than white or silver at reflecting infrared light. The light reflected by the enormous mirror is then focused onto the 30-inch or 74-centimeter secondary mirror, which is mounted on a foldable tripod opposite the large mirror. The light then enters the telescope through a hole in the center of the huge mirror, where it is directed to the detectors by a tertiary mirror. Once in space, these elements unfold, locking together. The jigsaw puzzle is so finely adjusted that the seams between the variant segments will be completely smooth once the mirror is entirely aligned. Webb, with its 6.5-meter mirror, will not only be able to acquire finer, deeper views of the universe than Hubble, but it will also be able to do it in a fraction of the time. The observatory features 4 scientific equipment that serve 2 main purposes: imaging cosmic objects and spectroscopy, which involves breaking light down into different wavelengths to analyze the physical and chemical aspects of cosmic materials. The James Webb Space Telescope will be around 1 million miles or 1.5 million kilometers from Earth. That's more than 4 times the distance between Earth and the Moon. The telescope will orbit the Sun while making short loops around the so-called Lagrange point 2, or the L2, a position on the Earth-Sun axis that is always obscured by the planet. At L2, the Sun and Earth's gravitational pulls maintain the spacecraft aligned with the 2 massive bodies. The spacecraft's tennis court-sized retractable sunshield is constructed of 5 layers of aluminum-coated space blanket material called Kapton, and without it, the mission would be impossible. The sunshield is the primary cooling system for the James Webb Telescope. The mirrors and 4 never-before-flown instruments would be kept at a temperature of 390 degrees Fahrenheit behind it, or minus 217 degrees Celsius. The sun-facing side, on the other hand, will be sizzling hot, reaching temperatures of up to 230 degrees Fahrenheit. The heat received by each layer is perfectly reflected away from the spacecraft through the gaps created by the 5 layers of ultralight Kapton material. The material is super thin and lightest, but it's also extraordinarily strong, with enough strength to withstand meteorite bombardment. Webb also has a spacecraft bus that houses its electrical power, propulsion, communications, orientation, heating, and data handling subsystems. In total, Webb weighs about the same as a school bus. To find our answers with the telescope, first, JWST must survive its scorching journey into orbit and a nail-biting set of events that have astronomers around the world wild with anticipation. However, this brings with it plenty of new obstacles. How do you lift something the size of a tennis court with a 21-foot mirror into space? For the telescope's launch, the mirror and sunshield, as well as the regular solar arrays and antenna, must all be properly stored in origami style. Unfurling is a complicated and difficult task, and it is the most difficult deployment NASA has ever undertaken. About 30 minutes after takeoff, the communications antenna and solar panels supplying it with energy will be deployed. It will take 6 months for the telescope to be unfolded and ready to go. JWST will bring exploring distant worlds and drinking in starlight. Planets will appear in silhouette as they pass between their stars and the telescope for a brief while, highlighted by the starlight shining through from behind. Webb will read the signatures of the gases the light travels through in that starlight. Webb will be the world's largest and most powerful space telescope. ESA is providing the telescope's launch service using the Ariane 5 launch vehicle as part of an international cooperative arrangement. ESA was in charge of developing and qualifying Ariane 5 upgrades for the Webb mission, as well as procuring the launch service from Arianespace, in collaboration with partners. James Webb will be encapsulated in the largest rocket, Ariane 5. The Ariane 5 rocket fairing, or nose cone, will shield the telescope during liftoff and its journey through the atmosphere. More than 10,000 people worked on the project, with the budget eventually snowballing to around $10 billion. The mission is set to last for at least 5 years, but hopefully 10 or more. The launch of the giant telescope has been pushed back several times, initially penciled for 2007, then 2018. The delay was mainly because of the complexities associated with development. But now the wait is over. JWST will launch this Christmas from ESA's tropical spaceport in French Guiana, which will be its penultimate earthly stop before sailing beyond human grasp. At first, the launch was supposed to happen on the 24th of December. However, due to adverse weather conditions at Europe's spaceport in French Guiana, the flight VA-256 to Launch Webb was postponed. The new target launch date is December 25th. Although JWST has yet to launch, scientists are already working on its successor, a big space telescope with the objective of discovering biosignatures on extraterrestrial worlds similar to Earth. Because such an instrument won't be ready for decades, JWST's observations of exoplanets are much more important in the meanwhile. What do you think about this masterpiece? Will it be able to answer the questions of our existence? Share your views in the comments section below. If you like the information, do give it a thumbs up. And don't forget to subscribe to the channel and click the bell icon for the update on upcoming such videos. Until then, have a great day, and thanks for watching.